So now we will put in relation the kernel functions and distance function that we saw with, for example, with the nearest neighbor classification. So in fact, when we are defining kernel functions, we are defining some kind of similarity metric. So we are measuring similarity between two instances. When we are talking about distance, we are talking about a way to compute the dissimilarity, the difference between 2 points, because bigger the distance, more different they are. So kernel and distance are kind of related, but they are kind of the opposite of something really similar. In fact, we can even define something really interesting in terms of mathematics, is to say that, you know, if we are using kernels to transform a given problem from something in d dimensions into something in higher dimensionality, we can compute Euclidean distance in that space, in that high dimensionality space, by using this. So we are kind of computing the square distance of Euclidean square distance, which is equivalent to having our kernel apply on X and itself. So XX, basically. So we have kxx here, we have kyy here. So these are like computing the kernel on this, the data for the same data for the two variables, minus kxy. So this has been demonstrated to be corresponding to the square of the Euclidean distance in the kernel space, the space spanned by the phi x function. So there are some examples with scalar project kernel. So if we just start with this scalar project, which is basically a kernel that is keeping us in the original space, and if we are developing this, we get into that. So we just say, okay, our squared Euclidean distance is equivalent to the usual Euclidean distance, should be that. I mean, let's develop this, which is equivalent to x minus y transpose x minus y. And if we are developing this a little more, we get into something like x transpose x plus y transpose y minus 2x transpose y. This is giving us this thing. And as such, you know, we remember that this corresponds to that. So this corresponds to kxx, this corresponds to kyy minus 2xty minus 2 times the kernel of x and y. So with this thing, we are able to make use of k-nearest neighbors classification, for example, with kernel functions. So basically, we just define a distance function in the space spanned by kernel, so we can apply all other distance-based methods with a kernel. So that's a nice result. That kind of relates k-nearest neighbors and all these things with kernel functions. And here we can even go further. We can say that, well, the supervectors that we get with SVM, for example, are more or less equivalent to prototype selection we can do, for example, with art so all the prototype selection methods that we saw before. So this is really nice to do that. So yeah, we also have the capacity to define what we call a gram matrix. A gram matrix is basically the matrix where we apply the kernel to each pair. So if we have a data set of n instances, we have n different instances. So we take all pairs of that and we apply the kernel on that. And we build, in fact, a matrix that is called a gram matrix, which is n by n. So we see that we have kx1, x1, kx2, x1, and just up to kxn, x1, and so on, kxn, xn, kx1, xn. So these are different cases that we care in terms of building up a gram matrix. And this is a symmetrical matrix. And that shape, that function, that matrix is similar to a distance matrix or even similar to a covariance matrix. Because for distance matrix, you know, this is also n by n. So instead of measuring the distance between 1 and 2, we are measuring the kernel between 1 and 2. So this is not that far. In terms of covariance matrix, you know, with SVM, from the primal to the dual formulation, we move from a d dimensions to a n dimensions problem. So we get from the W's, which are in D dimensions, to the alphas, which are in N dimensions. Same kind of approach can be done here, and where we will apply, I would say, everything that is needed to evaluate to make some computation over things that we're using covariance matrix, but instead we will use a Gram matrix.